Okay, this is the video solution for problem number 2 of the midterm given to lab section 52. Okay, uh, you're given the structure and you're asked to use the most appropriate element to model it, and the restraints are shown here. The edge of this circle is clamped, and these edges A, B, and C, D are subjected to a force of 100 pounds in the direction shown. Okay. Now, first thing you have to realize is that you must solve this problem with shell elements, okay? And then you're asked to identify as many planes of symmetry as possible. When you look at the restraint and the geometry and the loading, it is obvious that when you cut this structure like so, follow my mouse cursor like this, you cut it like that, and you cut it like this. So it's 1/4 of the model, 1/4 of the part that you really have to model. So the choice is yours whether you want to model the whole thing and then cut it with plane or model 1/4 of it as expected. So let me do that with 1/4, okay? Also notice that the sizes, the wall thicknesses are different, okay? So these two have the same wall thickness, 0.1, and this one has a wall thickness of 0.2 inch. Okay, let's start with a part. And since we're dealing with surfaces, we're going to do that in generative shape design. I'm not going to use surface extraction. I'm just going to make the surface directly. Okay, on that vertical plane, I will sketch that inverted L, so like so, like that. This one is 2 inches. This is 2 inches. And this height is 1. Okay. Oh, this is 2, right? This is 2. Okay. Exit and extrude it by a length of 1. Okay. All I need to do is to make some holes up here, one for the half a circle there, and also 1/4 of circle at the bottom there. Okay. So on that plane, I will sketch. Now, let me see that circle. For example, let me draw it there. It really doesn't matter which side you draw it on. Okay. And since I'm going to be cutting this top surface with that circle, I think we can try to see if we can cut it with just this arc, or we need to close it. Okay, we'll see. My gut feeling is I think we have to close it, but you can try it. I think you have to close this because we're going to use the split command, and I'm pretty sure you need to close the. Well, I'm not sure. I'll let you worry about it if you want to. So the diameter or the radius of this is what is that, 0.25? Yeah, 0.25. Okay, good. Exit. And then we're going to split it. Split, where's the saw? Right there. Split, read this thing carefully. Cutting element to cut is that surface. Cutting element is this. And this is fine. Okay. Now on that face, we're going to do another 1/4 of a circle, like so. Uh, we can actually do full circle. Okay, I'm pretty sure we can use a full circle, and the same radius, diameter 1. Okay, exit. No, diameter 0.5. The radius was 0.25, so there, that's better. Exit, and I'm pretty sure we can use the split to cut this. So split that surface with the sky, and yep, keep the thing that we have. All right, anything that we don't want, we can hide. So I'm going to hide this guy. I'm going to hide that. Let's see what else. What is this? Hide. Yep. Okay. Now, we're going to join these. Actually, I don't need to join it because of the way I made it. Remember, I drew something like an L and then extruded it. It's all basically, you don't need to join it. There won't be a seam when you mesh it along that. But if in doubt, you can always join. Now, let us apply material. I think this is out of made out of steel. Okay, and then we're going to save this thing. File, save management. File, save management. Save as. Desktop, a new folder, and this is midterm. Where did that go? Let's try it again. Uh, Cancel. File, save as. Desktop, a new folder. Okay, yeah. So midterm. This is section 52, and this is problem 2. And incidentally, it's shell elements. Okay, let's put it there. Okay, where did I put this thing? Midterm, right there. Save. Okay. Okay, now we're going to go to generative structure analysis. We're going to use shell elements to model that. There is the shell elements right there. I'll use the default size. This is fine. And linear, no problem. Okay, you can actually look at your mesh if you want. It looks like that. Okay, very good. Deactivate this. Okay, now the thickness. Notice that this top one has a thickness of 0.1. This one has a thickness of 0.2. So what I'm going to do is, there's two different ways of doing it because, well, let's try. Here is, look, this, you click on that, 2D property. When you select it, the whole thing is selected, okay? So we're going to put 0.1 on the whole thing, and then we change it to 0.2 for this one, okay? So support is this. The thickness is 0.2. The whole thing, what did I make here? Just 1 second. The top one is 0.1. So I'm going to make the whole thing 0.1. 0.1. Okay. And then we go here, right click. Oh, no, put it on 2D property. Right click, local mesh, local 2D property. And then we're going to select this vertical one and put a thickness of 0.2 on it. We have done things like this in class. Okay. So this one has 0.2. This one has 0.1. Okay. Now, I said in class that if you extract the surfaces, things are going to be uglier, and I didn't advise you do it, but it's up to you. Even if you did it with extracting surfaces and creating connection between these faces, etc., as long as you have done it, you're going to get your mark. But it's more work. That's fine. These thicknesses I don't want. I'm going to hide them. Okay, hide that one too. Now, what do we know? We know that this edge is, you see this edge is clamped. The whole circle was clamped, but we are modeling only a quarter of it, okay? And then these are on plane of symmetry. This edge and that edge and the one in the back, this vertical one, they're in a plane of symmetry. So let's do the following. Let's uncheck all of these so that we don't make a mistake. Select the edges that we want, this edge and that edge, and the vertical edge in the back. See that vertical edge, this guy? And these lie in the YZ plane of symmetry, so they don't move in X. And as soon as you do that, the rotations become obvious. It's the opposite. Okay, opposite means that if this is checked, this is unchecked. These are unchecked, these are checked. So that's what symmetry is. Oh, this guy, on the other hand, is also a plane of symmetry, in a plane of symmetry, but it's in the YZ, XZ plane of symmetry. So we need another one. That guy, that is in the XZ plane of symmetry, so it does not move in Y, and rotations opposite. This takes care of the restraint. Now we have a force acting here. This force acting on that face in the direction y, but notice that it was the entire edge was subjected to 100 pounds. So when you take half of it, it's going to be 50. 50. So, okay. I'm pretty sure that's it. So let's save our analysis file, save management, analysis, save as. This is the right folder, so we just keep it there. Okay, let's run it and see what happens. By the way, the force is here. You can see that right there, distributed force. Total force of 50 pounds on that. And then we're going to run it. Nothing exotic is going to happen. It's just that it's going to, bend, stretch and bend a little bit. Okay, that's it. This is the deformation. Okay. And of course, you can animate it. Sure. And you can plot them on meso stress. We don't have any confidence in these numbers because we have to do a mesh conversion study to get to the bottom of the things, and we haven't done that. So this is it. By the way, notice that if you look at the front view from the front, the symmetry. This is the side. The view from the side, the symmetry is maintained. Let me flip this. Let me take that. Okay, and you can animate it. Notice that because of symmetry, these edges don't go to the left or to the right, and this bottom edge does not go up and down as it's not supposed to, like that. All right, you're gonna stop this.